Rightio, this presentation will be talking about Dittmer and the surrounding areas. We'll start off with a quick corporate snapshot. Ballymore, listed in 2021. We have an excellent board of directors with Andrew Gilbert as our chairman, David A. Zitterden as our managing director, Andrew Gilbert as our executive operations director, and Nick Jaws as our non-exec. These people are just tremendous in guiding us forward. Massive discovery experience with Mount Wright, Ravenswood, Capricorn Copper. Our share price is 15 cents, our market cap is 26 million. 15 and a half as of 4:30 today. All right, there we go. That's brilliant. After the prezzo. Okay, we're located up in northeast Queensland. We have four main project areas, which is Mount Molloy just north of Cairns, Righty Gore surrounding Chillagoe, the Ravenswood project, which runs some charters through to Mount Wright, and the focus of today's talk, Dittmer project, which is a whopping 488 square kilometres just south of Bowen. Now, the reason why we pick these areas, this area, the region has produced over 40 million ounces of gold, and all projects I would consider as being vastly underexplored. So, tectonically speaking, we're up in the northern part of the Tasman orogenic zone, which runs from the Torres Strait up in the north down to Tasmania in the south. In Queensland, it's broken up into three main orogenic groups, being the Thompson origin from 510 to 470 million years ago, the Mossman origin up in the north, which is where our Chillagoe and Mount Molloy projects are. That's from 425 to 390 million years ago. And finally, Dittmer, over here in the northern part of the New England origin. So Dittmer. What we're seeing here is a pink section here. So we've just classified the geology into age groups. So what we have here is the Connors Arc sub-province of the New England origin, which is comprised of mostly igneous and volcanic rocks of Permo-Carb age. On the eastern side, we have rocks of the Camilla Formation, which are thought to have formed in a four-arc basin. Those rocks are typically volcanic, so tuffs and andesites. And on the western side, that's your Bowen Basin and Lizzie Creek volcanics. And at the end, late stage in Cretaceous intrusions have peppered this entire zone up and through here, which will be what we'll be talking about soon. So, Dittmer historical exploration. It was quite remarkable. Before Ballymore, no drilling, very limited soil sampling, fairly limited rock sampling, no stream sediments, no ground geophysics, so no IP, no EM, no magnetics, no gravity, and no detailed surface mapping. This is just an example of what we have from the underground. So you've got some very sketchy geological notes and some face sampling. And that's about the limit of the exploration that happened here. Absolutely astounding. But what we do have, and something I'm thankful for every day, is the underground workings, which Andrew Gilbert has gone to such a tremendous amount of effort and has done a tremendous job of making this as stable and as wonderful as possible. So what that has allowed us to do is to drill underneath the ground. So we've extended the adit, and we've got two drill cuddies, which are we're currently drilling from at the moment. And it has saved us thousands upon thousands of meters of drilling and millions of dollars. So the historical mine, it was discovered in 1934 and was producing gold until 1952 with some later production from 68 to 71. At the time, it was one of Australia's highest grade gold mines at 151 grams gold and 2.8% copper. This is just an example from 1945 showing the workings. So we're looking towards the east, south on the right, north on the left. And what you can see here is 6 levels. After this, there's a 7th level underneath. And yeah, that's about 200 metres long by about 100 to 150 metres in RL. The historical production was about 54,000 ounces, as I said, at 151 grams gold, and there is about 10,000 ounces at 6 gram worth of backfill. So I'd like to highlight this feature here, this little red line. So this, they've said the approximate cutoff line of ore. So as you can see, this line here is dipping towards the south. So I'm going to zoom a little bit ahead of the story because I wanted to show this. This is a long section of the drilling that Ballymore has completed. And clearly what you can see are high-grade southern plunging chutes. What's particularly interesting is between these chutes you get some low-grade material, which is to be expected. And what I particularly like is that along strike there's almost no drill holes over here, no drill holes over here, and it's completely open at depth. Already what we have discovered so far is 250 metres long, so it's already longer than the historical workings, and about 250 metres in RL, so already deeper than the historical workings. And why I say it's a discovery is because of this. So as I was saying, this is the main adit coming in, which Gilbert has done a great job of reconditioning, and these are the two cuddies that Ballymore have put in. So when these were coming through, the geologists on site noticed some nice fault zones there, and we put the drill holes in and returned some stunning grades. So 6 metres at 13, 15 at 3, 12 metres at 1.9, 2.5 at 1.6, 8 metres at 7, 9 metres at 3, 3 metres at 6. But what was most interesting of all is that it appears that the main lode is faulted and displaced about 100 to 120 metres up. So there's only 30 metre displacement from between those two lodes. Now, interesting, before working with Ballymore, I was working in the area, and everyone in the area talks about Dittmer. And they always talk about how high grade the mineralisation is. But everyone says, oh, it was mined out though, it was mined out. And clearly that is not the case. So this is a tremendous discovery on Ballymore's behalf. We've done over 61 holes for over 12,000 metres of drilling. Each hole has successfully intersected gold mineralisation. As I said before, it's open along strike and at depth. And this is what the lode looks like. You can see, quite simple. You get some altered wall rock, quartz, pyrite, chalcopyrite, and different generations of quartz. This particular one is from a recent announcement, 221 grams gold, 70 grams silver, and 2.7% copper. Absolutely pleasure logging this core. So from a model point of view, so we've been thinking and we've been modelling. And so what we see in the region, we see a close spatial association between the Cretaceous intrusions, between the alteration systems and the mineralisation being associated with the Cretaceous intrusions. We see far away from the Dittmer lode, we see propylitic alteration. Surrounding the lode, we see typical phyllic, sericite, silica, pyrite alteration. And then we have an enrichment factor, which I'll talk about next, of tellurium, gold, bismuth, silver, copper, and arsenic. And this is our conceptual model. So we think that there's some sort of porphyry intrusion down here driving this whole system. And yeah, there are differences with the North Queensland IRGS. So typically, the IRGS systems in Queensland are Permo-Carbon age as opposed to Cretaceous. And we seem to have more oxidised fluids than the typical more reduced permocarbs. And the evidence for the oxidised fluid is just here. So just down the road from Dittmer, not far, is the Lamington mine, which you can see, this is some of the ore from there. So there's quartz veining with specular hematite. It's absolutely stunning material. And this is high-grade gold in these samples. So at least one stage of the mineralised fluid was strongly oxidised. So a younger IRGS system. So this is Greg Morrison's classification matrix. So gold systems here, copper gold, copper moly, moly tungsten, tin. And having a look at our enrichment factors over here on the left. So this is based off drill core, multi-element analysis. And compared to a granodiorite background, we have tellurium, 7,000 times background. Gold, 1,700 times background. Bismuth, 192. Silver, 53. Copper, 47 times. And arsenic, 19. So looking at the tellurium to bismuth ratio, we end up sitting in the left-hand side of this graph. And looking at that elemental enrichment spread, plots us down here on the bottom. So what this tells me is that we are close to the high-grade core of the system. Like we still have enrichment in copper, silver, and arsenic, which suggests we're proximal to core. So very interesting to see what's going to happen when we get deeper into this system. So the exploration that Ballymore have completed, we have done hundreds of stream sediment samples. We've done hundreds of rock samples. thousands of soil samples, high-res aeromagnetics, surface mapping, underground channel surface and underground drilling. And the result of this, this surface soil sampling in this section here is a 2.5 kilometre long copper-gold anomaly. So the hard yellows and the hard greens are plus 50 and plus 100 ppm copper. Truly significant, and they plot beautifully with the known workings along here. But what's even more interesting is that we find repetitions of copper-gold anomalism running up and down the hills. So clearly, from an alteration and a fluid flow point of view, these hills are just leaking with gold, which is really quite interesting because some of the creeks are named Gold Mine Creek and Silver Creek. Just so I'd like to point out that this is 2.5 kilometres long. The extent of the current drilling is only 10% of that. That's 250 metres. Okay, discovery potential. We were very fortunate. In the last 12 months, we've been granted over $1 million in state government funding through the CEI program. I'd like to say a special thank you to the CEI team for all the hard work that they have done. We were very fortunate. In the last round, we received $250,000 in funding for a deep diamond hole into a magnetic anomaly. This magnetic anomaly is a three-dimensional model which was generated from the magnetics data which we collected last year through a CEI grant. And so the inversion model through here, and we are currently drilling this hole as we speak. So watch this space. It's a 400 metre by 400 metre pipe-like body, which it'll be interesting to see what we hit, particularly as the Dittmer mine dips straight down into this feature. So, like I said, this space, watch this space. So last year we flew a 100 metre line space differential system, the differential magnetic system, which theoretically provides a better product and a higher resolution than the 50 metre line spacing. What you can see here is a regional 400 metre line spacing. So RTP on the left, first derivative on the right. And this is the product from the 100 metre line survey that we had. Absolutely stunning. So previously, you look at the data and you go, oh, maybe we can see an intrusion here, maybe there, if I squint my eyes over here. But with this data, it's stunning what you can pull out. Absolutely magnificent. So this is just a quick, whoop, there we go. This is a quick interpretation of the intrusions in multiple generations. So we see here, these are the Cretaceous intrusions coming through here. These little features here, interestingly, we think that they are remnant magnetic permocarb intrusions, which are punching through into the Connor's Arc. These features have never been identified before. They haven't been walked over. Who knows what's there? It's absolutely stunning. And again, the same sort of data, but I just wanted to show one of my favorite magnetics models. So this is a ternary image. So red, green, blue, showing the reducer pole, the first derivative, and the analytic signal. And again, I just wanted to highlight how spectacular the individual intrusions have their own unique signature which pops through. And over here on the right-hand side, we have a ternary image of the radiometrics. Still on a regional scale, we have the historical stream sediment sampling. Now, I wanted to highlight gold, particularly because of the patchy nature. When you plot up all the historical stream sediment samples, it looks like a great distribution, like a really good coverage. But when you get into the data, you see that it's mostly copper, moly, silver, maybe, sometimes copper, lead, zinc. Sometimes, if you're very lucky, it has gold. So I've just extrapolated these out. These are 3-kilometre circles. So down here, we've got the Norman B. Gold Field. We've got Dittmer here, so you can see there's no stream sediments around. We've just had an announcement out today, which shows the excellent work that Ballymore has been doing in terms of the stream sediment sampling. So we assay for 4 acid digests, multi-element analysis with fire assay gold, and we've just returned a sample that has 40 ppm in the streams just over here. So beautiful, absolutely beautiful work that we're putting together at the moment. Over here on the right-hand side, it's copper. So you can see Julivon Creek, which is a low-grade sheeted vein copper moly porphyry. Over here, Evening Star, Andromache, Mount Quandon, Dittmer. So these potentially high temperature fluid areas. Lead on the left-hand side. Interestingly, surrounding Mount Quandon, which is a known epithermal prospect. And again, zinc on the right-hand side. absolutely tremendous how much fluid and mineralization has come through this area. That's over 30 kilometers of plus 100 ppm zinc. It's absolutely stunning. So what do we see from a prospect? We look at all the prospects within the tenements, and we've got some skarn up at Iron Knob. We've got rhyolite breccia pipes up at Moon. The vein, quartz sulfide veins at Dittmer. Stockwork veins at Cedar Ridge. Porphyry at Andromache and Evening Star. And massive lead, zinc, silver mineralization at Mixer. So we get a tremendous variation, which is just so exciting. Every time we come and have a look at this area, it's just amazing. From a classical model, we see propylitic alteration, we see phyllic. Down in the south, we see more potassic. When you're looking at your classical porphyry system, the amount of fluid and alteration that you see through there is just tremendous. And we're just so lucky. This is a conceptual section looking towards the north. So over here we've got the west of the Lizzie Creek volcanics and the Bowen Basin. The Connors Arc in the centre with the Cretaceous intrusions popping up through. On the right hand side we've got the Camilla beds over here. And conceptually we think that up in the north section we're higher up in terms of the erosional level. So Dittmer, the Iron Knob and Moon. And down in the south, we're potentially deeper within the system, so we get more porphyry, mixed with massive sulfide and Cedar Ridge stockworks. This will be the last prospect I talked about, and the reason why I talk about this, which I'll get to in a second, I've always really been enthused about this prospect. It was first identified in MIM back in the 70s, but they only assayed for copper and moly, so I walked away. MRD came back in the late 70s, early 90s, and lo and behold, assayed for gold. So 51 grams gold, 0.7 copper, 49 gold, 0.9, 14 gold, 1.4 copper, 18 gold, 1.2. So MRD came through and just strip mined the oxides and processed them at quite a few satellite pits at these tanks here. This is an example of the copper that we see at surface. And Ballymore rock chips, up to 3% copper, 24 grams gold, 155 silver, 137 moly. The historical production was 1,000 tonnes at 19 grams gold. But what I find most amazing is that at this prospect, there is no soil sampling. There's no ground geophysics, so no IP, no EM, no ground mag, no gravity, no detailed mapping. There's recon mapping, very limited blast hole drilling for in the pits, very limited rock sampling, good cosine coverage. And this is an image from the old MRD report. So you can see that's about 300 metres here, about 150 metres wide, and some just tremendous gold and copper numbers. I've said this many times, but it's just stunning how little exploration work was here. Now, if this project was in Western Australia, there would have been hundreds of drill holes. And I just shake my head and go, wow, what an opportunity. From the same magnetic survey, we completed the inversion modelling, and lo and behold, there's a magnetic anomaly sitting right underneath the Andromache. Which led us to our next CEI application, which was very luckily successful. And this is a plan view map showing these shells over here, and these are the proposed IP lines. Now this program should be starting in the next 2 or 3 weeks, and there's about 16 kilometres of dipole-dipole lines. And again, no geophysics. This will be the first geophysics completed at this prospect. So in summary, we hold a commanding position within the district. The project area hosts a wide variety of deposit styles. It's remarkably underexplored. The area is interpreted to represent a significant Cretaceous age IRGS province, and we have a huge potential for discovery. Thank you very much.
Thank you, Edward. You've got the dubious task of now answering lots of questions, because this is the biggest room we've had for a very long time, so I'm guaranteeing there's going to be a question or two out there. Who would like to ask a question? Way over here.
Thanks, Ed. Pretty exciting. Does it matter what it's intruding through in terms of the host rock? Because you have those things coming up through the Camilla beds. Is that a significant contributor to the potential?
Potentially. It certainly does matter in terms of the chemical reaction relationship between what it's intruding, how hard is it, is there anything reactive in it? So yes, but what's interesting with the Camilla beds, very similar to what we see at Charters Towers, so there's plenty of IRGS systems popping up through there, and yeah, no, I'd be very surprised if we don't discover something here.
It's fair to say, in the Camilla beds, you see a bit of variability from the classic talks to liquidity talks, and you generally do see a bit of a change in certain rock types where we tend to get more narrow, high-grade little zones, and others that smash them up into broader zones. So, yeah, that does have a control issue thing, but also, if you look further south, we feel we're looking deeper in the system, where we do see more classical sort of porphyry styles that tends to be more in routes and things that have us watch the operation supports that as well.
Always interested in structural control. You know, is there focus points? Is there key trends?
Absolutely, and we're in the process of working that out.
Oh, right, because you've got great data set there to work with and be really interesting to trace, because Fifield got a similar problem.
No, definitely. It's really amazing. When you're putting the data together, you can see there's a whole bunch of dikes coming through. You see there's faults which are coming in at different angles. And yeah, we're in the process of putting all that together. Yeah, so once we get a handle of it, then hopefully it'll make drilling a lot easier.
Yes.
Yeah.
Ed, great presentation, thank you. I was hoping to get a little bit of an update on the strategy and timeline for redevelopment at Dittmer.
And I'll pass that one straight on to Dave.
But you need to grab this, Dave.
You're going to get fit tonight.
Yep, the hospital pass.
Well, I was hoping no one would ask that question. Thanks, Mark. Look, we are obviously with the gold price at near historic levels, it's a great opportunity. We are very fortunate that not only do we have a very large exploration licence tenement holding, but we also have 2 granted mining leases, one of which covers the main historic Dittmer mine itself. We are hopeful that an expanded larger mining lease application, which we submitted about a year and a half years ago, will be finalised in the coming month or so. The intention is there's a real exciting opportunity to do a restart. It's probably fair to say we are speaking to a couple of different plants about opportunities to restart it. As Ed pointed out, there's not just a great opportunity with this newly found displaced extension to the old historic lode, but the backfill itself is, as I've seen in a couple of other places I've worked historically in Queensland, what the old timers called waste is now called high grade. So historically that backfill material, they hand sorted, that's how they achieved the 151 gram per tonne mineralisation that they produced here. And there was a very good reason for that. They were literally picking this stuff up, loading it on bullocks and then sending it either to Port Kembla down south or to Chillagoe. So we're talking often over 1,000 kilometres to transport it. The material that we're finding in terms of sampling, we've another advantage of reopening the old mine, it's allowed us to sample backfill material in a number of places. The lowest grade we've got for backfill is 3 grams per tonne. The highest, I think, from memory is about 82 grams per tonne. We think it is on average, well, median value, it's somewhere between 8 and 10 is what we're seeing. Look, so as I say, very tempting position to go and start it. The other advantage we have is because of the faulting has thrown up the load effectively within 30 metres of our existing mine. So look, our intention is hopefully with the latest infill drilling and extension drilling we're doing at the moment that we might come up with an initial resource. It won't be a huge one, but it will allow us to do that mine planning to look at the opportunity to restart a mine here on a small scale, which will hopefully then bankroll our subsequent work that we want to do in this area. We think there's a much bigger story here, but there is an opportunity for a small high-grade mine here. So look, in summary, there is a genuine plan. It may happen sooner rather than later. I won't give you a precise date because I'd be silly too. But we think there's a really exciting opportunity here. Just one other last comment I'll make is with all the work that's happening at the moment, Ed mentioned we announced some more exciting results from stream sediment sampling today, which has basically extended this corridor to about 4 kilometres. The magnetics shows there's a big DMAG zone that runs down through there. Structurally, it's quite a substantial area. We already have, through the soils, we've seen about 2 kilometres of quite significant soil, gold anomalous soils. and we think there's a much bigger system here. So we are looking to actually start development in the second half of this year to actually give us access to drill from underground to step it out quite a significant distance from where it is right now. So I've successfully rambled on for 5 minutes without answering your question. I think that's perfect.
Thanks, David.
Yeah, thanks, Ed. That was a great talk. Could I ask you, could you go back to the slide with your long section with the ore chutes on?
Certainly.
Oh, I'm looking at making it bigger.
Pardon? It depends. Joan, if you happen to find yourself up in Proserpine.
No, keep going. That one. Oh,
Yeah.
That was it. Would I be right in saying there's no drilling between the two chutes?
There are drill holes. You can see some points here. So yes, there are drill holes between the chutes.
Okay. Sorry? Well, no, I was just looking at notice that they're barren holes, but it says holes awaiting assays.
Oh yes, this one here is a hole away.
There's one up there and then there's one up the top.
And 58, that's right.
Yeah, I'm just trying to see between the two chutes. I'm not actually seeing any holes that are... Is there?
So again, Simon, you can see it's
Oh,
probably
one
not
hole.
so clear.
What, you got one hole?
There's one there, there's one there, there's another one here.
In a very small area. So you may not have you may have a much bigger chute. Yeah. Why not?
Well, yes, that sounds great.
I'm just saying, if I had $100 for every time somebody's come to me with ore chutes, I wouldn't be here now. I'd be having a holiday somewhere.
Hello.
Hang on, got one here, then we're back down there.
Interesting talk, Edward. The geology and exploration potential sounds great, but practicalities of getting the gold mine going so close to the barrier reef and cane growing and rainforest. What sort of opposition are you going to encounter?
Oh, that's an excellent question. There are some locals who are very anti-anything, but there's also a large amount of locals who are very supportive, and they want more industry and they want more jobs, particularly for their children.
Is it in state forest? Or?
It's in state forest,
Yeah.
that's right.
That's another problem. Yeah. Just being a party pooper, just being so close to the barrier reef, I'm just wondering what dramas you'll encounter from all the doomsdays.
I think we just work through it.
Oh, no, he was next. You have to get everyone to line up.
Your magnetic anomaly that you've got funds to drill out, it looks like you're pretty confident that you've got an extension through there. I'll wait till it comes up.
Almost there. This one.
That one there, yep. So you've got a plan B in case you don't hit it?
Well, we'll work that one out in about a week or so. There are always options. Potentially we could wedge earlier up the hole and shoot off to the side. We see quite a swing in the NQ towards the north, so there are options that we can do.
Yeah, I've got it now, Ed. Thanks very much for that, Ed. That was great. Bob's got his hand, but no, I've got it, Bob. Two questions, one at a small scale and one at the bigger scale. If you go back to your long section again.
Long section?
I don't know if it was my eyes, but
there we go.
North of the historic mine in the near surface, is there any drill holes in there?
No.
So if you project your high-grade chutes towards surface, are there no holes north of the mine?
No. So again, that's why we're so very excited, because potentially it comes up through here.
Yeah. Some more.
Yeah. Oh, because we have the EPM around this as well. Yeah.
Okay. Well, no, but they had different cut-off grades, right? Yeah. And my bigger scale question is, have you considered doing some MT?
Have we considered doing some NT? I think we have considered doing some MT, but for the CI grant, we needed it to be more innovative.
Yeah, yep. No, I've been working on a porphyry epithermal deposit in Indonesia, and it's a glowing MT anomaly. I'd recommend it. It's cheap and you can cover a huge amount of area with MT. 2 4-kilometre space stations. It is very useful. I don't know why everyone doesn't do it as a first pass, first pass assessment of your property, but especially if you're looking for porphyries. But good job, Ed. Thank you.
Thank you.
Probably don't need the mic. Is the Cretaceous age well established?
It is. We've had dating done on the mineralisation at Dittmer, and that squarely sat in the
question
Cretaceous.
is, are Cretaceous plutonic systems in the region totally underexplored?
Absolutely. I can say that absolutely they are totally underexplored.
I reckon we can do 1 or 2 more questions for Ed.
Just wondering if you guys have done any MET testing on this, because with the tellurides and stuff like that, that gets me worried, because normally the recovery... Yeah.
Go for it, Dave.
No, we have done some prelim. We've done 2 phases of MET test work. It's actually been exceptionally good recoveries out of it. We've actually done both cyanide leach and also flotation, and also in the last lot we tried this new whiz-bang non-cyanide leach method called Envirometal, which also reported each one of them's achieved over 90% recovery. So it is looking very promising in terms of its, despite the fact that we talk about tellurides and things, the tellurides are there, but the gold itself is typically free milling. It's actually very well behaved. It's been quite an exceptionally, and a very kind ore body to us so far from what we're seeing. And it also floats really well, which is also quite handy given there's a fairly significant flotation plant about 80 kilometres away.
Thank you, David. One last for anyone? Going once, going twice. Oh, one last hand. Oh.
So from the Camilla beds, when you come south, as you remember from second year field camp at Rocky, they're the berserker beds that sit in those carboniferous grabens, and they become, instead of the volcanics, who knows what they are, because they're berserk. And so I'm just curious along strike if there's any opportunity, because those Cretaceous plugs come all the way down through, as well as tertiary plugs. So are there any tertiary plug plays?
I don't know about tertiary plugs, but I know definitely that further south the Cretaceous plugs and intrusions along there are known to have at least copper and gold. So yes, there's lots of potential. And I think Queensland is tremendously underexplored. We need more exploration.
Sorry, Ed, your one question became 2.
That's okay.
Oh, sorry. Yeah, because I've been working with that the granite, the host rock granite a little bit. I've got those samples a little. So I just curious because you mentioned you got the age date for the mineralization. What is the age? What is the differences between the mineralization age and also the igneous intrusive age for the granite?
Okay, I'll pass you on to Dave for this one.
Yeah.
Thanks, Ed. Yeah, look, they're actually very closely, very close. We were very fortunate to have Alexandria Moses at James Cook do an honours project last year. She found some monazites sitting associated with the alteration around the lodes at Dittmer. Age dating from that, from the top of my head, is 138.1 million years plus or minus 2.1 million. And that's basically fits it very nicely in the same age range as the age dates that we've got for the Hecate granite, which is just be clear about this, the mineralisation we see here, and this is what first prompted us to think that there's an AIG-GSAQ-ALS system here, is that pretty all the mineralisation we see here, regardless of style, sits in basically this hornfelsing around the adjacent edge of that Hecate granite pluton. And we often see, later dikes and things punching up associated, which often have mineralisation either within them or associated adjacent to them. So we were pretty confident even before we saw this age dating that there was this later event that was responsible for our mineralisation. But now we're really pleased with Alex's work because it really does confirm what we already suspected about the age being this later Cretaceous age, because it was quite tempting to assume it was going to be another permacarb thing, but it's clearly not.
Excellent. Thank you very much. And one last round of applause for Ed and for all the extra questions he had to answer.